This is Geometry, Chapter 2, Section 5, in which we will study postulates and paragraph proofs. The idea of a postulate is one that we like. A postulate, which some books will refer to as an axiom, just in case you hear that word come along later, you'll know it means the same as postulate. Either way, what we're talking about is a statement that we accept as true without having to prove it. And a lot of our basic ideas about lines and points and planes come to us in the form of a postulate. For example, something that we already knew, through any 2 points that you can think of, you can only draw exactly one line to connect them, one straight line. Okay, picture 2 points in your mind and try to connect them with a straight line. And hopefully you see you can only make one line through there. Now, if we allow curve shapes, there's any number of ways to do it, but with a line, there's only one. And the same idea applies to planes in Postulate 2 too. If you have 3 non-collinear points, then there's exactly one plane that contains all 3. Now we can reverse these 2 postulates a little bit and get 2 more postulates. Postulate 2-3, a line contains at least 2 points. Well, we said before, through any 2 points there's a line. Now we're saying if you have a line, you know there's for sure 2 points on it. There's actually an infinite number of points, but at least you know 2. And with 2-4, it's related to 2-2. If you have a plane, then you have at least 3 non-collinear points. Again, you have an infinite number of points. But you know for certain there are 3 of them. A few more postulates here. If 2 points lie in a plane, then the entire line containing those points also lies in the plane. Okay. If 2 lines intersect, their intersection is exactly 1 point. Picture 2 lines crossing. They only cross once. Again, we're talking straight lines, we're not talking curves. And if 2 planes intersect, even spelled correctly, then their intersection is a line. We already knew that. Again, picture the ceiling and the wall. Where they intersect, you have a straight line across there. And we can use these ideas to explain our reasoning as we go along. Because one of the big topics in geometry is to be able to prove things are true. And the idea is we're going to use deductive reasoning, like we talked about last time, to move from the hypothesis of a statement to the conclusion of that statement. And the logical argument that you're building is called a proof. Now, when you're doing a proof, you're going to make a series of statements that lead from the original hypothesis to the original conclusion. You're going to have to take me through the steps to get there. And not only do you have to make statements, but you have to back them up. You have to support them by a reason. Now, your reason could be a definition, it could be a postulate, it could be another theorem. Oops, I said a word I shouldn't have said yet. Forget I said theorem. But it could be anything that we know for sure. We just have to be able to say this is how we know it. Once we've proven a conjecture, then we can call it a theorem. And we can use a theorem to prove other statements later. Okay? One thing you cannot do is use the statement you're trying to prove as part of your proof. It would be like saying a table is a table-shaped object. Doesn't really help. There are a number of different methods for writing a proof. And over the course of the year, we're going to go through all the different methods. But regardless of what type of proof we go through, some things stay the same. You always need to list the given information. They're going to give you some information in the problem to start with. You have to have a place to start. And if it's possible, you draw a diagram to show it. Sometimes it's not possible to draw a diagram for it, but if you can, you should. The second thing that's always there is you need to know what you're trying to prove. Think of it as traveling somewhere. You need to know the destination to know which roads to take and which turns to make and so forth. If you don't know where you're trying to get to, you certainly don't know how to get there. Now, once you know what you're trying to prove and where you're starting, you create what we call a deductive argument, forming a logical chain of statements that link the given information to the conclusion you're trying to reach. And each statement you make has to have a reason. You have to be able to justify what you say. Think about this kind of like you are a prosecuting attorney. You can't just walk into the courtroom, point at the defendant, and say he did it. You have to prove that he did it. You have to show your evidence. I know he's guilty because his fingerprints are on the knife, and we found the knife at his house, and we found the victim's blood on his shoes, and so forth. You have to prove with the evidence. Okay? That's what you're doing here. You're proving something. You're stating the evidence that makes where we know it's true. And then at the end, you have to state what it is that you've proven. Think of that as your closing argument type thing. Now, we said there are many different ways to prove things. The first one we're going to look at is called the paragraph proof. When you do a paragraph proof, what you are writing are complete sentences. This means subjects, this means verbs, this means punctuation. You have to do it. If you just start slopping things down, it's not going to work. You have to be able to prove what you're saying. And you're all big boys and girls. You can write a complete sentence, I promise. So let's practice one here. Given that M is the midpoint of segment XY, they want us to write a paragraph proof to show that segment XM is congruent to segment MY. Okay. First thing we need to do is state what we're given. We're given that M is the midpoint of XY. And we said we should always draw a diagram if we can. Well, we can draw a diagram of this. We can draw a segment XY, and we can put a point M on it at the midpoint. And what are we trying to prove? We're trying to prove that XM is equal to MY. So now we're ready to write our proof. And we start with the given information. We know M is the midpoint of XY. then knowing that that's the midpoint tells me something. Because the definition of midpoint tells me that it makes two congruent segments, or two segments of equal length. Well, those two segments are xm and my. So I'm making a statement here that xm and my are equal, and I'm backing it up using the definition. Now, since these two segments have the same length, the definition of congruent says that that means they're congruent to each other. Statement, xm and my have the same length. Reason, they are congruent. Thus, since I know they are congruent, I can say xm is congruent to my, which is what I was trying to prove. So I've gotten there. Now that we've proven that statement is true, if m is the midpoint of segment xy, then xm is congruent to my. Now that we've proven it's true, we can use it as a theorem. And this particular one has a name. It's called the midpoint theorem. So we'll state it formally now. It's theorem 2.1. It's the first theorem of chapter 2, and it's called the midpoint theorem. If m is the midpoint of a segment AB, then AM is congruent to MB. Okay, notice we changed XY to AB. It really doesn't matter what you name that segment, so long as you make that adjustment here as well. Okay. You've probably heard from older students that proofs are hard. They do take some work, yes. Everything worthwhile in life takes effort. You just have to not give up on it. It's going to take some thinking, it's going to take some time, you're going to have to get used to it, and I understand that. But you can't just say, oh, it's too hard, I quit. If you do that, we'll be seeing you again next year. You have to work at this. It takes time, it takes effort, it takes energy. And like I said, everything worthwhile does. So keep a positive attitude. Don't give up. Work at it. You can do it. If you had questions along the way, hopefully you wrote those down. And we'll see you in class.